So, Jai Hind everyone. Myself is Nikhil Kumar, the faculty of IT department in Ajay Kumar Garg Engineering College. So, today we have the lecture series of the DSTL, and that is the code the BCS 303. It is basically the for the second year course, second year subject DSTL for the IT and its allied branch. So, for DSTL, we already discussed the set relations, the partial order set. In the last lectures, we discussed the partial order set, the properties of POSET, and how we will prepare the hash diagram. So for today, we will take some examples to prepare the hash diagram, and we also take to build up the hash diagram from the given partial ordered set, and also take some extra questions that are based on the types of the hash diagram. So firstly, we take one more questions from the hash diagram. So just take, let's suppose the given set is 1, 2, 3, 6, 12. Okay, and the divisibility relations is mentioned. So construct the hash diagram. So let's suppose this is the question. We know the element are 1, 2, 3, 6, 12, and the relation is given as the divisibility relations. So we know that when we prepare this one, so at the bottom point, at the base point, we take the element 1 here, then 2 and 3, that will be comes to the same position to 1. Why we put the both the element 2 and 3 at the same level? Because that are the multiples of 1, and 2 is not the multiple of 3, or 3 is not the multiple of 2. So we will place the same value. Then we will place 6 here, then 12 will be placed here. So that is the particular right answer for the given hash diagram. Why we put this value here? You know very well that 1 is the bottom value, 12 is the top value, and these 2, 3, 6 is placed in the formations at the intermediate positions, because 2, 3 will placed at the upper positions from the 1 and the same level, because there is no any connections between 2 and 3. But 6 are directly connected to 2 and 3. So we connect the relations between 2 to 6 and 3 to 6. Let's suppose there is a formations. Then let's suppose that 3 is not connected to 6. There is a relations just like the divisibility relation is not mentioned. There is something different relation. So we will prepare that 1 to 2, then 3, and 2 to 6, 2 to 12. It may be the positions. It may be the given hash diagram. In the particular case, when there is not the divisibility relation is mentioned, there is something different relations where 2 to 6 is given, a link is provided, but 3 to 6 is not mentioned. So we avoid to link the 3 to 6. So this is the right answer for the divisibility relations. Now we come to the next one. Here in the given question, given the set A, B, C, D with the following relation, that means A less than equal to B, A is less than equal to C, and B is less than equal to D, and C is less than equal to D. So how we will prepare? Because we know that in that particular case, A is the less element. A is the element that will be placed at the bottom position. Then B will be placed at the top of the position. Then the top position from the B have the position to the top position to the A. Then we will get that A to C then C to D and B to D, that means D will be present. Just look these formations. I think this is the right answer for the given question, because A less than B means A's position will be placed before following the B. So we prepare this one. Then A to C, then we prepare A to C, then B to D and C to D. This is the hash diagram. So as per the given relation is mentioned, note the divisibility relation, something different, that means less than, equal to, less than, greater than, and then the other divisibility and symmetrical difference and the addition, subtraction, multiplication, and that something else other than the divisibility relations. We also prepare all the different concept of the mathematical terms using the hash diagram. So we takes as the given terminology, that is the operations what I was mentioned. So we take the next one. Here in the questions, the consider a set S that has the element A, B, C, D, E with the partial order given by the following hash diagram. How many relations are in the partial order? Okay, so what are the different relations are mentioned? So firstly, we will take that there is a relation 1, 2, 3, 4 and 5. So there are particularly 6 different relations are mentioned, but due to this we have also the relation that B to E, A to C and A to D is also be given. So totally how many relations are in the given partial relation? So we, when we count, that is the total 9 relations are mentioned, where 5 are the direct, that means A to B, B to C, B to D and C to E and D to E. These are the 5 relations, that is the direct relations is given, and 4 are the transitive relations, that means A to C, A to D and B to E and B to A to E. These are the 4 different relations that are based on the transitive relations. So total 9 relations are given. We take one more questions, that is we have the divisors of 30. That means how we will prepare firstly, and we have the relation that is the ordered by the divisibility. So construct the hash diagram for the set of positive divisors of 30, and we will take find out the all the factors of 30, that is 1, 2, 3, 5, 6, 10, 15 and 30, and we maintain the relation on that particular element and prepare the hash diagram for this one. So firstly, and the relation is the divisibility. So firstly we will write down at the top position, at the bottom position, that is the one element, then we will prepare 2, 3 and 5, then we will prepare 6, then we prepare the 10, then we prepare the 15 and 30. So this is the right answer for the given questions. Why we prepare such formation? Because just look at this one. One is the at the bottom positions at the base value, then 2, 3, 5 will be the top one at the next level, because there is the multiples of 1 and both these elements are not connected with each other any formations. So we put 2, 3, 5 at the same order. After that we have the value 6, because 2 and 3 have the multiple of 6, so we put this value here, but 5 have the multiples of 10 and 15, so we put this value, and 30 will be connected with 6, 10 and 15, so we will put the value here. Just look this one, that 3 is also connected with 15, so we connect this one formations. So this is the pending one. If this such type of formation is mentioned and necessary, we can use here 3 to 15 is also have the relation, because 3 have the multiple of 15, so we connect 3 to 15, but it avoid the transitivity. We will not prepare the transitivity, mention the transitivity. If we prepare 1 to 15 also, then it avoid the concept of hash diagram, so we avoid the transitivity relations directly. Now we come some more questions, that is draw the hash diagram of A less than equal to, where A 3, 4, 12, 24, 48 and 72, and relation is less than equal to B such that A is less than B, then A divides B. Okay, so how we will prepare? Take the value, we put the value 3, 4 here, then 12, then 24, then 48, then at the last 72 here. Can you think that this is the right answer? Because these elements are based on the concept that less than equal to is based on the concept of that A divides B. Yeah, this operator is represent that A divides B. So we put as per the given element, as per the given relations, that 3, 4 will be placed at the bottom level, then 12 will be placed at the upper level, then 3 and 4, then the 24 will place at the upper level, then 12, then at the last moment the element 42, 48 and 72 will be placed, because these are the multiple of 24, because 24 into 2, 48, and 3 times 24, 3 is 72. So we put these value. So we take the next question, that is the set A that contains some element. We ordered the relations. We ordered by the relations A divides B, then find the hash diagram. We have the same formations just like the previous one. So firstly, you try to solve out this question with yourself, then check out this video further. Firstly, we take the element 1 here, then 2, 3 will be placed here, then 4 will be placed here, then 6 will be placed, then 8, then the values of 9 will be placed, then 12, then 18, then 24, okay. So this is the formations. So we paste this one as the given terminology, okay. Here just look that we connect with the element 4 to 8 and 4 to 12. Why we connect the 4 to 8 and 4 to 12? Because 4 have the multiples of 8 and 4 also the connect with the 12 value. It also avoid the transitivity. There is no any transitivity is mentioned. So we avoid the reflexivity, that means 1 to 1, A to A connections is we avoid the reflexivity and the transitivity. That means if we connect 1 to 3, 3 to 6, and we also connect the 1 to 6, then it will be the transitive relation. So we avoid this one. So this is the right answer. So draw the hash diagram of the POSET that is based on the concept that these are the sub POSET element, and we prepare the hash diagram for that one. So we take the concept just like the previous one questions and solve out these questions also. So next terminology is the what is a lattice. So a lattice is a type of partial order set, that is POSET, in which every pair of element has the least upper bound LUB, and the second one is a GLB, greatest lower bound, that is known as the infimum and supremum. LUB, least upper bound, have this different name, that is a supremum, and the next terminology is the GLB, greatest lower bound, is known as the infimum. If a hash diagram contains in its property in the hash diagram have the LUB and GLB for each of the element, then it is known to be a lattice. Otherwise we can say that it is not the lattice. There exists a supremum also called the join. So LUB is also known as the join element, and it is known as the meet. So LUB have the two different names, that is the supremum and the join, and GLB, greatest lower bound, have the infimum and the meet operations. The key property of the lattice, existence of join and meet, that is based on the commutative, associative, idempotency, and the absorption law. So these properties are satisfied in the lattice. We know very well that what is the commutative. The operations will be based on the GLB and LUB only. There is some difference. They are the type of the lattice. That means first one is the bounded lattice, second one is the distributive lattice, third one is the modular lattice, and last is the complete lattice, and last one is the complemented lattice. So what are they? The first one is the bounded lattice. That means a bounded lattice is lattice that has both the GLB, greatest element, and the least element. That means GLB and LUB present. 0 element and 1 element is present. That means it is known to be a bounded lattice. The next one is the distributed lattice. If let's suppose A, B, C are the element, if it satisfies the distributive property, then it is known to be the distributed lattice. The next one is the modular lattice. A modular lattice is lattice where the following modular identify hold for all the element A, B, C and C. That means these are the executive elements that follow this property. That means A less than C is derived that the A join B meet C equal to A join B meet C. This is the necessary condition. If this property is satisfied, then we can say that is the modular lattice. That next one is the complete lattice. A lattice is said to be complete in which every subset has both the supremum, that is the LUB, and the infimum, that is the GLB. In other words, any collection of element, finite or infinite, in the lattice has a well-defined meet and join. So that is known to be the complete lattice. So next one is the and last one is the complemented lattice. A complemented lattice is a bounded lattice where every element has a complement. That means each and every element that are presented in the given lattice have its complemented. And what is the complemented value? That value should be complemented through which we can comes to the GLB and LUB value. Let's suppose to have any element and we find out what is the value of the complemented value of 2. Let's suppose C is present here and that is the complemented value. So when we find out the values of 2 and C, then the GLB and LUB values are 0 and 1. That means have the GLB and LUB is present for the C value. So C element will be the complement. A question is given that there are 3 elements A, B, C, and we have the GLB and LUB for A and B. And we prepare the lattice that have the connections subset. So we know that is the power set. P is represented as a power set. For the A, B and C element, if A, B, C element are mentioned, so for the power set will be P of, let's suppose A is given, we will prepare phi. We will have phi A, B, C, A comma B, B comma C, A comma C, A, B, C, so these are the particular elements for the power set. So firstly we will prepare the hash diagram for given element and we will find out the connections between A and B and find out the GLB and LUB value for the particular of the pair of A and B, through which we can identify that have the what are the value of the LUB and GLB. So for I think that it is sufficient for today's lecture. So thank you class for joining us. Thank you very much.